Hi gents, we're back again, and we're going to talk about a nice topic that we've covered quite a few times in this show in various different situations, but we'll start talking about EPCs, Energy Performance Certificates. So, I mean, there's millions of them produced every year. For those who may have seen them when they buy a house, which is typically the time when these things get generated, and they have, they're loosely based on the calculation is called reduced data SAP, standard assessment procedure, but essentially it's a indicative representation of that home. And one of the counter arguments to having these done is that we're now in a position where data is becoming more and more readily available. And we see it firsthand. I'm sure you will have come across this when you're doing your performance estimates, but when we receive people coming in looking for the energy saving advice that we offer, they will first thing is to connect their smart meter to our platform, and we will see their energy data. And we think that's a great step. We think that's if you're really interested in this journey, understanding your energy profile and how and when you're losing energy. And we've got some great stories of homeowners that were like, I didn't know why my electricity consumption was so high. They went on the platform. They saw a significant spike in electricity at a certain time on a Sunday, 1 o'clock on a Sunday. And they were like, we were always out at 1 o'clock on a Sunday. Only the kids were at home. And it turned out the kids were firing up the hot tub every time they went out and having a party with their friends. So it does release some unforeseen things behind the scene. But seeing that data, seeing your energy usage, and one of the biggest challenges we have when it comes into kind of heat pump assessments is we are told, as you were, we have to have an EPC done because the performance estimate has to be based on 2 lines within the EPC, which is the space and water heating kilowatt hours, which quite often are not representative of the home.
You also need the EPC to be able to get the BUS grant, the boiler upgrade scheme grant. So that's the only reason we had an EPC done, because our house had never, it wouldn't have had an EPC done. Because it was built before they came out.
So they have to be
10 years.
Within 10 years, yeah.
So I looked on the website. You can go onto the government website and type in your postcode, and it brings you up all of the EPCs in your street or in your postcode. We didn't have one, so I've got a friend who does EPCs, so he came around and did one for us, and it was just a paperwork exercise in effect.
You didn't look at that and go, I've got some really good value.
No.
I don't think anyone's ever looked at it. They've got really good value out of that.
I think that's the sad part. It's actually because it's nowhere near to the level of detail in the assessment process that you go through. But I always think when we do our initial energy audits, we're limited at the front end, and we try and encourage the customer to kind of move down a bit of a journey with us. So we get the smart meter data. We have a built-in physics model that has around 1 million house types. So we ask questions to identify the closest matching one. Each one has a load of data in it around house performance, various different times of the year, and different kind of occupancy profiles. So it takes them on a journey. But one of the big factors is we don't, if you like a digital twin of that property, knowing what the floor area is, knowing what the walls are like, knowing what the window sizes are, the kind of thing that somebody's gone to the property and done, maybe not a detailed measurement to the extent you would, but it would be useful to, in terms of that early stage qualification process, to have that visibility. And what we tend to find is that information it's certainly not publicly available. You can get EPC data and you can get some information from the back end of the EPC, but those physical calculations and measurements and floor plans, if it's not on a Zoopla website somewhere, it's sat with a certification body somewhere. So actually the really useful part, nobody actually gains access to. And then ultimately the output. But as much as you would have used it for the boiler upgrade scheme, I'm assuming when you did the performance estimate, you would have had to put that information in there.
Yeah, you have to put it in, but the actual, the details it gives you isn't correct though either, because the annual space heating demand and water demand are usually way out of kilter as well. So then when you put that in to show a fuel comparison cost, the usual comment we get back is, well, that's 3 times the amount I usually pay now. And I know that. I've got to show you this because it sort of gives you a comparison, and they're so far out. But I mean, most homes will probably have a smart meter in now that can record half-hourly data. I just don't understand why they're not just digitalised.
Yeah. Oh, and certainly to the extent of being able to offer that as an alternative methodology.
Just to put something in.
Because especially when you we've seen it when we produce the performance estimates ideally for the consumer to take to people like yourselves to then say, right, okay, here's what I have so far, a starting point on the qualification journey. But I think it's interesting when you do put that in front of them, because it kind of, if that is linked to a return on investment or an estimated performance, it becomes disregarded pretty instantaneously on the basis that just the space and water heating consumption, is say 2 or 3 times higher than maybe the whole home consumption. Yeah. And I found, I came across this quite recently, that if you're doing a solar design for somebody that also wants a heat pump, you can't take that into consideration in terms of their electricity profile.
No, and you also, if they've got mechanical ventilation, heat recovery as well, you shouldn't really take that into account either.
Really,
it should just be what is the heat loss of that home.
Is that assuming that if
that broke and the heat pump's then undersized and all the rest of it? But surely it's got to be an holistic view of the whole thing. Yeah. We've got to get to a point where we're using all this technology together, and even to a point where, I mean, just for the bus grant alone, someone could have a whole, let's say they've got first floor, second floor. The whole first floor has already been done previously with air conditioning. So they've got aircon units in all the bedrooms because they wanted some cooling. But I can't take that into account to size the heat pump.
You've got to do it on 100%.
I've got to do 100% of the house.
But then surely I suppose it's one thing with, okay, don't turn your aircon on. But actually, if you've got mechanical ventilation heat recovery, outside of the heating benefits of it, you're also getting the ventilation benefits of it. So people do run these things for better air quality. But you're also oversizing the heat pump, I assume, then in that circumstance.
Yeah, well, in both circumstances, because if they're going to run the air conditioning, which they could do heating for, then I'm going to size it for that when I've already potentially got a 7 kilowatt heat pump sitting there for the upstairs bedrooms, or a 5 kilowatt heat, whatever it might be. Why can't we just bring all this technology together and use it? Because otherwise we're then increasing the demand on the grid as well when we don't need to. But we could just use everything, just let the technology work together. And
that's how the customer will use it, though.
But because that's the bit that gets missed from it, is that they say, you've got to do this, but the customer doesn't want that. So you're like, I've got to work around this in a way. And then when they get the EPCs and they've finished it, I think the hot water. So we've had one where they've done the EPC after, they had to have it upgraded because it was out of date. So it's been upgraded. They've got the heat pump in there, and they've recommended to put the hot water to like something else. They said, well, no, it's on a heat pump. It's better than what it was. Yeah. And they've told it that they should need to upgrade their hot water because it's not efficient because it's on a heat pump. And you're thinking,
because it's down as electric.
Because it's a lower scope. Yeah, because it's down as electric heating, but it's not. It's not 1 for 1. It's at least 100% more efficient than that.
It's so bad though, isn't it? Because we've seen that as well. We've seen people come in, they've had an EPC done after they've had the assessment done for whatever reason, and they've got a lower score, now they've got a heat pump.
But
I mean, so part of the monitoring systems that we do a really basic, it's just a gateway with some temperature sensors. And we say to people, we give them an indication what it might look like to have a heat pump fitted, and they might not be ready at that time to go ahead or whatever, but they can purchase one of these gateways with the sensors in, and we use that alongside external weather data and the smart meter data to calculate something called the heat transfer coefficient.
The build test solutions, they do a similar thing, the HTCs,
And the aim is that, with that data, you can obviously size the heat pump, but it also enables us to, especially if they put a sensor in each room, we can start to monitor the heat loss of an individual room in the property. But also the speed at which the system's reacting. So we get, you mentioned before, the kind of the dial you have on the boiler. We get the customers to, in the winter months, they throttle the boiler down to 50 degrees, for instance. Then they can see on the platform their gas consumption to what level that's reduced. But they also get to feel the comfort in the home and say, it's a bit like having a heat pump trial.
You can lower it down and have a look, see if it can cope.
But you can see those energy saving components. But we find firsthand, actually doing these conversations with the customers, because they come in at all from different avenues. I would say the majority of the people that register on our platform have never even heard of a heat pump.
No.
They come on and it's usually a bit of a cry for help. I need help. I need to save money on my energy bills. And little tricks like that, like turning the boiler down within reason, depending on the make and model. We talked before, things like draft proofing, all these little things you can do that we can give them a kind of visual representation to actually see the savings in real time. But the value of that data and then being able to calculate what the heat loss is, we then say, well, we can provide that to an installer to help you do the quote. But then you still have to go in and then do a room by room heat loss calculation, putting the measurements into two tools that are perfectly good tools. But in some cases, the results are extremely different. And one is a measured result over a 12-month period, and the other is based on assumptions in terms of wall fabrics and what have you. And we put that forward to MCS as an alternative methodology to say, well, if this has been done, surely this is of a greater level of accuracy than somebody going in and measuring and assuming what's in the walls. And as it stands at the moment, you still have to do, even if they have one, you still have to do.
So the heat loss done, We've done it before with the jobs where we've done the full heat loss, but we've looked at it and gone, it seems high with what the customer's telling us about how they run it and stuff. So we've used the build test solution to put the sensors around the house, run it for 3 weeks, and got the heat transfer coefficient, which has come out lower because the CIBSE guidelines on air changes, for example, we know could be twice as high than what the actual UK housing stock is on air changes. So you get one report which is telling you that's the heat loss of the house, and then you've got your professional knowledge, I suppose, from what you've done and what you've seen and what you've fitted, that you can go, actually, it's not a 10, it's a 7. Like we can fit a smaller unit in here. But then you're sort of looking and thinking, well, that's bloody telling me that it's that. And you've got to really sort of own it and then go, no, my professional experience, I know it's less.
I can back this up. And I suppose you can always then tweak the heat loss calculation.
Yeah, you sort of look between the two and you play with it a bit, and you speak to the client and you say, like in my own house, for example, the back door of the kitchen is always open because the dogs are in and out all day long. Yeah. So I know that that room has a much higher air change than the rest of the house. So by talking to the client, you can get a sense of how the house is going to operate. And
you start getting to that point of being able to measure it. But I would imagine as well, when you do your heat loss calculations, you produce, excluding the EPC data. Does the calculations, do they give an indication of kind of kilowatt hours for heating hot water and space heating?
It will give it based on what heat pump you're going to put in, so what temperature you're going to get it to, and endoscopic things on that, and then how much water consumption you think you're going to have per person per day. So I think the industry standard is 45 litres per person per day, which I think is actually more than what we do. So if you've got a 4-bed house, for example, you're going to do it per bedroom to size the cylinder, which is nuts, So I think we store too much hot water anyway in this country. We can store a lot less. So it's that conversation with people, like with John's, we didn't change it to an unvented cylinder because to do that, we'd have had to have run a 22 mil cold main from one side of the house to the other. And it was just madness to do it, So we just put it back into a vented position with a bigger coil in it, and it works perfectly fine.
But this data that comes out of the assessments, how much did you kind of view this? Because you've had an EPC, and it sounds like you've relatively disregarded the information within the calculations that Mark produced around, not necessarily around sizing, but usage. Was there information within that you looked at and kind of disregarded it equally to the EPC?
Can I answer that in a slightly different way? I think the most useful information in the heat loss survey was the radiator sizings and watts per room. So which radiators we needed to change, which were underperforming, and which ones would need to be upgraded to bigger radiators, and which were our worst performing rooms, which sort of confirmed what we already knew by how we felt when we walked into a particular room.
That was so if a particular room was
chilly,
you knew that the output of that radiator wasn't quite enough. And did you do anything leading up to that around setting temperatures on boilers? Were you just
we did actually. We ran a year with our old gas boiler, our 22-year-old gas boiler at number 1, lowest setting. No idea what number 1 actually equates to.
I don't think anybody does.
No. And it coped, but it was barely okay. But that was with our old radiators and microbore pipework. So we knew that it should work once we got a heat pump in. So that gave us faith that once we obviously talked to Mark and he did the stats and said, yeah, it'll work.
It's an interesting one though, because there is there's a school of thought. So we had a similar situation that physically being able to extract that temperature data out of the system without being too intrusive of fitting heat meters and things like that. So we with that gateway we have a little kind of strap on meter that just monitors the temperature when we fill it up, just to give you an indication of what the temperatures are that those gauges of 1 to 5 or whatever actually run at. But when we've seen that and people have dropped it down to 35 and they say not quite coping, then they might take it up to 40 or they take it up to 50. They find that kind of sweet spot. We've also seen it then when people have gone out and done the heat loss calculations, and when you then get to the radiator selections, there's a set of correction factors for based on output of energy. This is how it performs. I don't want to be too kind of zeitgeist with this view of the world, but those correction factors have come from radiator manufacturers who, the chances of you ever replacing those radiators in your home, unless you were going for a heat pump, means that you're probably never going to be another sale for that radiator manufacturer. Whereas you make this with the calculations and you come out the other way. And we did we looked at the data from the electrification of heat project. There was about 750 installs that went in the northeast, and the data that came out of that, Energy Systems Catapult processed this data and they kind of release it publicly every year. And under the Heat Pump Ready program, we did a research study between the physical designs that were done on those installations, the design calculations, the heat loss calculations, and the actual performance of those systems. And what we found on pretty much every single one was the system was never meeting the design temperatures that it was designed at. It was running far more efficient than it had been designed at, which is fantastic. Nobody's going. But and obviously it was great from a statistical point of view, and it was great to see that these systems were actually performing better than we'd assumed. So there was no issue of mis-selling. But the critical part that came out of the report was how many people didn't go ahead because of those level of upgrades, be that from cost or be that from the fact that the size of the radiators would need to go in those rooms just wasn't either aesthetically suitable or practical. And we did kind of say there's a bit of a call to action there to say, if obviously we favour monitoring because it's what we do, but actually that true monitoring of a system being and minimising the level of how intrusive it is. And I think Build Test Solutions is a great example of somebody who's also doing that. If you start to understand how that system is performing, you could calculate those radiators outside of a leap of faith of saying, I'm going to put a heat pump on this install and at best I can run this at 65 degrees if it was a high temperature system, and then see how the system performs. Periodic upgrades.
I think there's a big way in which that can actually get heat pumps done faster as well in the country, just installing the heat pump. So I think let's just say, for example, every single house when they had a heat loss done by a professional, they got someone in and they got that data and said, right, these are the radiators to go to 40 degrees or whatever it might be. Okay, you take that information and as you go around your home and you decorate, upgrade the radiator, put the new radiator in or all the rest of it. Or we're going to have some electrical work done in the garage. So whilst you're doing that, get the rotary isolator fitted for the heat pump where it's going to go outside.
Yeah.
So you can step your way into a heat pump installation. Where we're building all these new homes at the moment up and down the UK, they're not going to have heat pumps on them, all of them. No. We get that. But why aren't we fitting a heat pump base outside? Yeah. And why aren't we putting the rotary isolator on the outside? So at least some of the work is done. Let's design all the radiators for a 55 or a 50 degree flow temperature maximum, So a lot of the work for these houses is already being done. So when it comes to actually then fitting the heat pump, the cost is halved because the base doesn't have to be fitted. The soakaway is already in. The rotary isolator is already there in a position that works. We can just pop the heat pump there and then we're in.
And I guess even
the primaries.
Yeah, well, that's it. But even potentially even winning the primaries, I guess.
You could put something in. So even if it goes up the cavity into the loft space, so there's something there. So you can drop into an airing cupboard, for example. These things can be done.
It's called the term that came out of. I think the Heat Pump Ready program was probably one of the biggest successes of the net zero innovation portfolio. Certainly, some of there's some great work going on in there. I think it's Stream 2, where some of the design solutions kind of sit. But that term of heat pump ready, I think, is essentially what you're saying there. It's how do you get a home to be heat pump ready?
Yeah.
And unfortunately, what we tend to find at the moment, and I think this comes as a bit of a shock to people, and I think you experienced it with the delay for planning as an example. But if it wasn't planning, it could have been upgrading the cutout rate into the property, disconnecting a loop supply where your electricity comes in from next door or vice versa. Those delays ultimately mean if somebody's in a position where the boiler's broken, you've got no real option. And I think we did a market insight study, which I think was probably one of the most interesting pieces of work I've worked on in my time in this industry. And it started off at looking at people that were having smart meters fitted in the home. And I can't remember the number, it was something that's 50 or 60% of the people who were in the study, the response back was, you won't be able to connect to mine because it's in my drawer. So they generally thought the smart meter was the display.
Yeah.
So a little bit of education around that. But what we found was in pretty much every household, there was somebody who was responsible, I'm going to say, for the finances.
Yeah.
And then there was, and that person was the person looking at the in-home display. And it can become a bit of an obsession, So what happens is you turn on the kettle. Do you have any idea how much electricity you use? The big one was people who had children, especially like teenage children, how long they were spending in the shower. And what you had was this kind of solo individual, fully responsible for the financial situations, very much obsessive about this thing. And the rest of the family were like, this is my home. I'm comfortable. I don't want to hear this every time I want to go for a shower or make a cup of tea. So there was a huge emotive driver over here and a very emotional thing. And then there was this kind of impact financial driver over here. And what happened was eventually this person got beaten down so much that they put it in the drawer.
He puts it and gets rid of it,
And then we found the interesting kind of part of the transition that goes on. First of all, we found that we were engaging more with those people because they were the people that were kind of like, my family aren't listening to me about this. It kind of a bit like a therapist, an energy therapist. It's like we on the other end of the phone going, we understand. We understand where you're coming from. But it was the moment the boiler broke, and this is what we found actually when we were communicating with these people on the basis that our job is essentially that by the time the boiler breaks, it needs to be ready for somebody like you to go in,
come in and do it,
and ensure that they don't fall into the pattern of another boiler installation. So we were engaging with those people, giving them an ear, a kind of shoulder to cry, and you can have that conversation with us, because their family weren't listening. And the reassurance was, at some point, you're going to be the person with the cape on because the boiler's going to break.
Yeah.
And everybody's going to look to you because the comfort's gone. We're not warm anymore. We haven't got hot showers. And they look to the finance business and say, can you please fix this?
Yeah.
And all of a sudden, this person's in a very elevated position. Now they can start to make some of these decisions. If your answer at that point, when you're the savior, you can make this decision, you're going to change the fundamental infrastructure of this home to make it renewable. And your answer is, bear with me, 4 to 6 weeks and we'll get this back on.
No.
You're back at the bottom of the
pile again. It's just going to be a gas boiler going. But then
Yeah.
if on the flip side of that, if you look at it from an engineering perspective, like you constantly hear there's not enough engineers, there's not enough skilled labour, there's not enough trained labour, there's not enough of this, there's not enough of that. Okay, yeah, that's fair enough. There isn't. If it's in a one hit, boom, we're doing it. But if you look at the job in its entirety, the skilled person is the person who has designed it, and the person orchestrating the job doesn't necessarily have to be on site, but it does help if they are. The rest of it is general plumbing and heating. So if you're going to get heat pump ready and step toe into it, as long as the professional, you'd like to think, has done the heat loss and they've sized the rads and they've told it all, as long as the homeowner has got that report, a general plumbing heating engineer can go and replace all them radiators. So there is enough skill up and down the country to do it, but it's how we approach the job is how we're going to transition. If you just want it all done there and then on the turn, there isn't enough skilled labour to do it, because there's, for the amount of administration and everything that goes into it for heat pumps, there isn't enough probably skilled or willing. Willing is probably the best one for it to do it. But if you step toe in and you do it over a 6-month period, right, we're going to decorate that room, right, we're going to change all them rads, the cylinder needs upgrading, we'll get that bit done. If you do it as you go along, then within 12 to 18 months, you're probably at a point, right, now we need to get Mark in and we'll come and fit the heat pump. The job is now so much smaller. It doesn't need all that labour onto it. The only downside of that is the VAT. It's VAT free and you get the grant and everything's all bundled up. It can make it more cost effective that way.
But I guess that final point, when you actually, if you take the grant as a consideration, if all you're doing is the heat pump and the controls,
it can be very cost effective.
Yeah. And I guess from your perspective, John, when you were going through this, obviously you've looked at this as a complete package solution, and obviously Mark has come and delivered a complete package solution. But was there no? You mentioned you'd dropped the temperature down. You'd seen certain rooms were performing. Did you have a consideration in your head that you were always going to go for a heat pump? Therefore, I'm not going to worry about making those, let's say, periodic upgrades to those radiators. Or was there ever a point at which you thought, I'm going to just upgrade those first, or was it always you wanted a complete solution off one person?
A complete solution with a guarantee install that it would work.
Yeah, that's true.
So with a Heat Geek install, it says, well, it'll perform to this, and if it doesn't, we'll fix it till it does.
And I wonder what the situation would have been in. So let's say you had decided that you were going to upgrade, from your own back, you decided that you were going to upgrade those 17 radiators over the period of 2 years with local resources. And then you came along and did your assessment and you went, you know what? Actually, I don't need to upgrade any radiators. The system is aligned to what you've got. You would have still had to give that same performance guarantee, I assume.
Yeah. Oh, yeah, because it's still based off the same heat loss. So if the radiator output is that's what it is, then that's fine. It's the same as if you took the radiator from the lounge and you put it in the upstairs bedroom.
Of course.
Yeah. You can still move them around the room. We were just upgrading all of them in John's house, and that was it.
What happens to the old ones?
It's landfill, scrapped, aren't they? With scrap metal, they just go.
It's such a shame, isn't it?
Yeah.
I mean, I suppose it all depends on I guess, as you
These
said,
were all original with the house. I mean,
I
think
they've served their purpose.
I don't think any of them had actually ever been replaced. No, they were all original. I mean, as much as we can, where we've got modern radiators, we will try and move them around the house if we can, unless the customer specifically says, no, we're going to replace them all. One of the customers we just done one for in Bedford Road, they have a local charity that if the radiators are of good quality, they will clean them out and they'll redistribute them to people who, so the stuff does get upcycled in some areas. I can't talk about everywhere, but I know.
That's such a good thing, because with all the positives that come with it, if we are stripping them out, and I've seen it happen with, boilers that are 1 or 2 years old.
Yeah.
People have moved into new build houses. The first thing is I want to get, my previous house had a heat pump. I want to put a heat pump in this house, and the boiler gets taken out. But I think there's, you'll know better than me, but is there's some regulation around if you take a boiler out of somebody's house, you can't go and fit it back in somebody else's house.
Shouldn't be doing it. I mean, it will happen for sure, but it shouldn't be happening because it's already been used. But we done one on a brand new building site, and it had never been turned on. The house had sat there, and we took it off, heat pump straight in before the customer actually moved in.
Really?
And they took it off, and someone else used it.
Yeah.
At that point, went in his house, but they wouldn't even put it into another house on the property.
And there is I know I say people will do this, but just from a regulatory perspective, I think there's something with gas safe that says
you can't. No, you shouldn't be using
because it's already been the serial number's already been picked, and that goes the same. I think is it for heat pumps. You couldn't re-register a heat pump under MCS if the serial number has already been used, I believe.
Yeah, well, you can't. Well, for the bus grant, you wouldn't be able to reuse it.
Yeah, if you're going to take it away, it's just an interesting one that obviously, for yourself, you've already had a heat pump, you've had the bus grant, but if you move to another house and you try to take that and then notify it under building control,
it's already been notified against that property.
Yeah, so you couldn't even you could do it, but again, by the book, you shouldn't, and that's kind of a little bit like, well, you've paid for that, But
it's because you could take your solar and you could take your batteries. So why couldn't you take your?
Yeah,
you could take your air-to-air units as well, couldn't you?
Yeah, I think there's something with the heat inside of it, though, isn't it? You can't take it from a property and leave that property with no heat and hot water either, as well.
Right.
So there's the building regulations.
Probably a difficult sell for the new home.
Yeah, so big gaping
as you're
holes in
leaving
the wall.
you're doing your itinerary and you're saying, no, I'm taking the curtains, I'm taking the rails, obviously the heating system. It's a bit of a miss. But we've been doing some work with a company called Solar Zero out in New Zealand, and they do these solar and battery long-term rental programs, and it's relatively commonplace over there. You own the solar and you own the battery, and if you move home, you take it with you.
Right.
It's essentially you clip it off the roof, the bracket's left in place, the battery's disconnected, and it's made safe, and they go over. And then a big sell for them is when the new person walks in is your home is solar ready. And obviously
I don't understand why there isn't essentially like a leasing model or something like that in this country where you can link it to your mortgage.
Yeah.
Like, it just makes sense for me because, one, it would enable the mortgage companies to offset carbon through your carbon production. So you could lower the mortgage rates, I imagined, as well from that.
Absolutely.
And then if the customer was to move from that house, then that debt would be repaid from the equity of the home. But if you could leverage that onto a mortgage over 30 years, you might be talking £10 extra a month.
There's an incredible one. It's an organisation called Perenna. They're a relatively new mortgage lender in the UK. They're bringing out. We're working with them under a project called the Green Homes Finance Accelerator, and they've got this long-term fixed rate mortgage. So you can basically fix the mortgage for 30 years, maximum 30 years. You can lend against that mortgage to put the solar and the battery equipment on. But if you can demonstrate that your consumption has reduced by more than 20% by having the technology installed, which with solar and battery it will, or with a heat pump it absolutely will, they drop your rate for the entire mortgage for the full term.
Oh, that's good.
And essentially it gets to that point you said, the rate, the amount you're paying on your mortgage to have the technology fitted is actually the increase is then deducted from the lower rate. So you end up in a position where your net spend is no greater, and you've got the technology in your home. It's a great initiative, but it has to. This does go back to the kind of EPC point really, and the data. We've been doing a lot of work with lenders on, why aren't more lenders in this space? Not just mortgage lenders, but financiers and the finance that you can get your hands on. I saw a rate the other day for a solar install, and it was 14% to finance.
We get emails probably every week from finance companies saying, "Oh, we'll give you finance for these deals," and that. It's 0 to 12 months interest free. No one's going to be paying this install over 12 months. They're looking for 10, 15 years or something at a decent rate. And why are you offering 15%? It's just, I can't get my head around it.
And the people, the people that can then gain access to it are of a level of creditworthiness that they could walk into any high street bank and get a loan for 5 or 7%.
Yeah, you're not going to do it.
You're just not going to take it on. There's no viable reason for that to happen. And then the lenders. So the conversations that we've had with the lenders, we've spoken to some really great lenders under the Energy as a Service project about coming in on those long term ones, and the biggest hurdle they have is that the UK's lack of data on performance of homes. The smart meter, the data is improving that position, but the lenders under kind of consumer credit law and they essentially carry the can. So if you did John's install and it was under a finance deal and you promised certain levels of performance and the next day you disappeared and you've got a problem, the lender legally carries the can, and they're saying at the moment we haven't got if the only reliable resource that's being stated as the thing to go to is the EPC, they turn around and say, well, we can't rely. We actually had one lender who did quite a bit of work on the performance estimate side for heat pumps. They were trying to create a finance model called heat as a service, and one of the biggest challenges they had was if you provide the customer with that report and link it to a finance deal, they said that it would be classed as mis-selling. And our argument back was, well, the actual performance is going to be far better. And they said, but equally, that customer could come back in 5 years' time, even if they didn't take it, and say, you have cost me X amount more in my energy over the last 5 years because the information you provided me with stopped me going for a heat pump.
And they just do it flip. And it's also to the point, if you say the house is going to be heated to 20 degrees and then they turn it up to 24, it's not going to then match that report at the same time. So the report, it's like an MOT. It's only as good as you give it to them then. In the day. And then if they change it the next day, it's gone. Yeah. But with all the data that you can pull off, like Open Energy as well, Heat Pump Monitor and all the rest of it, you can see that and how good they're performing. And then if you do give a guarantee on it, when you go through the grant with MCS, I have to have an insurance-backed guarantee and then a consumer code.
Yeah.
But they don't pay out on anything.
No.
So you pay all this money out to these people and nothing happened. So if I was to do a bad install and just left, the customer's just left carrying the can. We see it all the time.
Yeah, there doesn't seem to be the recourse it kind of seems to be kicked around. It's like the consumer, the competent person scheme.
Yeah.
My understanding is they ultimately should carry the can.
Should.
But then they will say, oh no, this is an error in the contractual information, which is then the consumer code.
Yeah.
Or it'll be, no, it's an error in the design calculations, therefore it's an MCS certification issue. Yeah.
And they just kick it all around the can, but then they take £600 off you each a year.
Yeah. Plus how much now is it per installation?
For the insurance-backed guarantees, I think depending on the level of the length of time and the contract you've got with them, that could start anywhere from £30 to £100, depending on who you get the insurance-backed guarantee from.
Yeah.
But then you've got your yearly MCS subscription, you've got your yearly consumer code subscription, and your competent person scheme subscription.
It's a wedge on top, isn't it?
Yeah, it's massive cost, but none of them do anything.
And outside of
what you're paying for.
Yeah, because obviously having that certification gave you access to the boiler upgrade scheme, and it gives you access to administer the boiler upgrade scheme voucher. When you were looking, you obviously found HeatGeek as your first point of reference, but were you aware of the microgeneration certification scheme, the relevant competent person schemes, and the consumer code? No. Which is, I think when you think about, what was a startup now grown obviously into the business they are now in HeatGeek, that became more of an authority and probably is now more of an authority, and the self-policing of the engineers within the network than the physical scheme itself.
Yeah, HeatGeek themselves are the consumer code, the competent person scheme, and MCS all in one.
And yes, you don't operate to it, you get booted off.
Yeah, that's it. So if you do a bad install and someone goes and audits it and it's not right and you're not going to repair it, HeatGeek have the power to say, well, you're not installing for us anymore. But the assurance fee that you pay for is essentially, we'll class it as a pot of money, if you like, to pay for me to go and rectify that install to the standard it should be. But that's no further cost to the customer because they've already paid for that install.
And that's what you get from HeatGeek.
That's how they do it. So as an umbrella scheme, that essentially it is, if you like, because they're acting as the main contractor there. I don't think there's a better one in the country.
It is interesting because ultimately all those things that are in place, they're there to protect you. That is the purpose of them. They're fees in which you incur, which ultimately get passed on to the installation fees that get quoted. But I assume post installation you will have got all the MCS certificates and
yes, they all came through
the warranty registrations and stuff like that.
Yeah,
but I guess as a reputable installer, you would, if you were not a reputable installer and the thing went wrong, then is that going to make you go back to site? Because I assume if you had that piece of paperwork and
you see that all the time on the forums, where customers are throwing their hands up to say, what do I do? The installer's saying, no, it's not their problem. MCS saying, no, it's not their problem. they're completely, tied. No one's got any teeth basically to do anything.
Or no one wants to put their teeth on it.
Yeah, I wonder where that comes from, though.
Well, whoever takes responsibility of it's got to pay for it.
Yeah.
That's the biggest risk on it. Whereas, if you look at a lot of the installations that go on, they could be a national company or whatever, and they've just subcontracted it out or whatnot. It could be anything. But the customer is still in the middle of that, not knowing what to do, who to go to, or how it's going to be rectified. Now, we'll do our own installations as Custom Renewables. We'll do our own because we're MCS registered, but we also do work for HeatGeek. But all of our customers, we want to keep them forever. So whether we do a job through HeatGeek, for example, we recently serviced John's after the year it had been in. That's a job we took on because he's a customer of ours. Mm-hmm. And I think that's the key difference with the umbrella scheme with HeatGeek is that the person who does the install tends to or should keep it for life because it's usually a customer of theirs or it's in their area. It's not someone from here going to a job in Brighton. It'll be a local installer for that local customer.
That's good as well, though, isn't it? Because then I suppose you have continuity as well, don't you? If the standards if everybody follows the same standards and the work is done to the same standard, then actually, I mean, I don't know, is there a specification that you have to install a certain manufacturer or? At
the moment, they link it pretty much to Valent.
Okay.
But I'm sure, I don't know their roadmap, but there will probably be other manufacturers that maybe go in that. But it's usually the best products. They're not going to fit. I mean, they've got their own they've got their own cylinder they designed themselves. That my business partner and Adam designed. That's it's a fantastic cylinder. So they're pushing the mini store is another example. They're innovating the industry as they go. So I mean, the Valent heat pump, it's a fantastic bit of kit anyway.
But I guess there's the continuity then. So you've had a Valent heat pump as well. But if say it can be if you got hit by a bus tomorrow.
Oh, it's the same heat pump. So all the installers are fitting the same kit. They're aware of the same equipment.
And it becomes a bit wider than that where a Valent engineer could come out and look at the Valent heat pump, but actually a HeatGeek engineer can look at the combined solution in the system. Yeah. Like they, I guess, will understood the approach you've taken and how you've done it.
And done the whole lot,
yeah. It's such a, we actually have somebody from Heiss coming on in a few weeks' time, and that's one of the questions that we want to put to them really is what is the what should be getting flagged to consumers to add that level of security and protection? Because I would imagine if you're offering a insurance-backed warranty from a workmanship perspective, there's got to be something sat behind that that's underwriting that insurance policy. And I would imagine the insurance providers behind that are saying, if you're getting 60-70% complaints and issues and claims against your installations, they're either going to retract it completely, or they're going to ask for you what are you doing to improve the quality? But when these are possibly no different to car insurance providers, it becomes a numbers game. You want as many registrations on your books, and obviously further incentive in that every installation that you do notify becomes an additional fee that you pay. If somebody's out there doing £2,000 installations a year, but they're getting lots of complaints, that actually becomes a very commercial decision to take somebody off, both for the certification body and the
finance. They're losing all that revenue as well. Yeah.
It's a minefield.
Yeah, it needs changing, but we'll see what happens.
There's good ones out there.
Yeah. Oh, yeah, without a doubt.
So I think we need to make sure so it's Custom Renewables.
Custom Renewables, yeah. So that's me and Lee and Barry, my business partner in there, and we install all types of renewables, solar, PV, batteries, everything.
Region-wise?
So pretty much anything north of London, from Norfolk to Gloucestershire, across the middle section there.
Right, okay.
But for the right project, we'll probably go anywhere.
Get a hotel. And what's the website?
custom-renewables.co.uk, or you can find us on all social media as Custom Renewables.
Any good case studies and things like that?
There's a few on there, yeah. And obviously John's YouTube channel, which he can plug in a sec, has got our install. You videoed the whole thing as well, so...
Oh, go on, John, give us that. That's the YouTube channel.
It's John Tisbury, actually, quite straightforward.
John Tisbury, straightforward enough.
Yeah.
And is that you? Is that personal? Or is that the glass? You mentioned the glass business as well.
That's Fired Glass. That's also got a YouTube channel. But the John Tisbury one is my journey with all the solar, and
Oh,
I did
fantastic.
monthly solar stats and buying EVs and all those kind of things. So what we've done for the home, really.
Excellent. Well, we'll make sure we link to that. We'll make sure we link to you both in the comments on when they go live.
Perfect.
Thank you very much for coming up. It's been a long journey, but
No problem.
hopefully you've
Worth it.
enjoyed it.
Thank you very
It's been
much.
really
Yeah,
informative.
it's good.
Cheers, gents.
Brilliant.
Thank you.